So, we've been talking about the 6 trigonometric functions. We've been assigning values or finding the values for trigonometric functions of specific angles, okay? Now we want to actually use that information to learn the graphs of the sine function, the cosine function, and actually learn transformations of those graphs. So remember when we talked about functions, before we talk about trigonometric functions, we talked about shifting functions up or down, to the left and to the right. We're going to do the same thing with the trigonometric functions, okay? So we first need to know their graphs, okay? Start out with the definition. A function f is periodic. It is periodic if there is a positive number p such that f of t plus p is equal to f of t for every t. The least such positive number, if it exists, is the period. That is the period. That is an I there. Of f. If f has period p, then the graph of f on any interval of length p is called one complete period. Of f. Okay, so you'll see one complete period here in a lot of books, or just when you hear a lot of mathematicians talking, you hear one cycle. One cycle is the same thing as one complete period. Okay? So now let's graph y equals sine of x. What is sine of 0? 0. What's sine of pi halves? 1. Good. What is sine of pi? 0. What is sine of 3 pi over 2? Negative 1. Good. What is sine of 2 pi? 0. Good. So you connect it all. That's your graph. That's sine of pi. Now you can keep going, right? But this is one period. This is one period, or we say it has period 2 pi. Well, I don't have to cover up 2 pi, right? We have period 2 pi, okay? Again, you can keep going, right? Sine of negative pi over 2 is negative 1, and then you have 0. So the dotted line just means it's not a part of that one period. It's just showing you what the rest of the graph looks like.
What is actually the period 2 pi?
It's just an arrow.
So what is it called?
It's just an arrow. What other questions do you have? Okay, so that's the graph of sine of x. So some properties of sine x. The domain we've talked about already is all real numbers. The range, your y values consist of the numbers between negative 1 and 1. Okay, the sine function is periodic with period what? What's the period?
Oh, 2 pi.
2 pi, good. Sine is an odd function. Remember, we talked about odd, even and odd properties in the previous section. Sine is odd and is symmetric with respect to the origin. The y-intercept, where the graph crosses the y-axis, is at 0. And the x-intercepts, notice that the x-intercepts are multiples of pi. So n pi, where n is an integer. Okay? Let's talk about, or let's sketch the graph of cosine of x. Let's sketch the graph of cosine of x. Okay? Cosine of x. What's cosine of 0? 1. Good. What's cosine of pi half? 0. Good. What's cosine of pi? -1. Good. What's cosine of 3 pi over 2? 0. Good. What's cosine of 2 pi? 1. Good. So we can graph this function like so. Let's make sure we go all the way there. This is my sketch, right? You can make your sketch a little bit better. So, turns out this is 1 period. This is period 2 pi. Okay? You can finish graphing, or you can graph more of the function if you like, and it'll look like so. This point would be 5 pi over 2. This point would be 3 pi. This is negative pi over 2. And this is what? What's that? Negative pi. Good. Okay. Now, properties of cosine of x. The domain is all real numbers. The range consists of real numbers between -1 and 1 here. Okay. The cosine function is periodic with period what? 2 pi. Good. Cosine is even and is symmetric with respect to the y-axis. Notice the symmetry here. Okay. The y-intercept is 1. This is where cosine crosses the y-axis. The x-intercepts are multiples of pi halves except for 0, right? So you have -3 pi over 2, negative pi over 2, pi halves, 3 pi over 2, etc. Okay? Those are your x-intercepts. Periodic properties of sine and cosine. Periodic properties of sine and cosine. The functions sine and cosine have period 2 pi. Sine of t plus 2 pi, what that means is sine of t plus 2 pi is equal to sine of t. Cosine of t plus 2 pi is equal to cosine of t. That's what that means. So now what we're going to do is we're going to sketch the graph of each function. So remember what cosine of t looks like. We graphed it above. Now what we want to do is sketch the graph of -2 plus cosine of x. So it's going to take, so first let's sketch cosine of x. So cosine of x, use a marker. Cosine of x looks like, one period of it looks like that, right? So again, you can mark your x-intercepts, your y-intercept. So that would be 1. Then this would be pi. This is what? 3 pi over 2, and this one is 2 pi. Good. So that is cosine of x. That's the graph of cosine of x. F of x equals -2 plus cosine of x is going to take that graph and do what to it? Now you got to remember your transformations. It does what to it? Is it on the inside with the x? It goes down. Remember, if your number is on the outside and not, so you said shift it to the right. Shifting it to the right means you would have something that said cosine of, would it be x minus or x plus? X minus 2? But we're not doing that, right? It looks differently. So because that -2 is on the outside, good. So note the difference. Okay, so we shift this function down 2 units. So now it's gonna cross at -1 here. So graphing that looks like this. It looks the same, but shifted down. Okay? So this point here is now -1. What's this point? What's the y value for this and this?
It ran through that, or -2.
You shifted it down 2. 1, 2. Shifted down 1, 2. What's the value, what's the y value here and here? What's the y value here and here? -2. Good. That's the y value there. Good. So just extending it so you see what's happening. That's -2. And then this point here is what? What's the y value? -3. And I'm pointing this information out so you can make sure you understand domain and range information. Okay, so the green graph is the one that we actually want. That's -2 plus cosine of x. What questions do you have? Okay, all right, so let's take a look at the next one. Part B, we want to sketch the graph of f of x equals 2 minus cosine of x. 2 minus cosine of x. Okay, so the first thing we should definitely sketch is what?
Wouldn't it be the cosine x, like what we just did, the second line, and then up to?
No,
It'd be negative cosine of x.
we want to graph negative cosine of x, right? We want to graph negative cosine of x because this is negative cosine of x here. So graph that. So negative cosine of x. Remember what your values are. So we can start by plotting points. What's cosine of 0? What is cosine of 0? 1. But remember you have a negative out here. So that's -1. So that means we have that there. So I'm going to write down specific x values and we'll find the corresponding y. What's cosine of pi halves? 0 times -1 is? 0. Good. Cosine of pi is? -1 times -1 is? +1. Good. We'll say that's right there. Cosine of 3 pi over 2 is? 0. 0 times -1 is? 0. Good. Then you have cosine of 2 pi is? 1 times -1 is? -1. Good. So this gives us 1 period of negative cosine. Gives us 1 period of negative cosine of x. So this is negative cosine of x. Now, since we have 2 minus cosine of x, what do we need to do to this graph? Shift it up 2. Good, shift it up 2. So we move up 1, 2. So now it's going across there. So we have this. This is my sketch. Make sure you interpret it properly. Let's see if we can make it a little bit better. That doesn't even look right. That's better. It's the same, just shift it up. Okay? So this point we know is 1. What would this value be and this value be? What's the corresponding y? 2. Good. And what's the highest point, the highest y value? What is it? 3. Good. So that's 2 and that's 3 if you extend it. Good. So the blue was 2 minus cosine of x. Okay? All right. In general, for the functions y equals a sine of x and y equals a cosine of x, the number absolute value of a is called the amplitude. It's called the amplitude. And it is the largest value these functions can actually attain. It's the largest values the function attains. Okay, so sine and cosine curves. So the sine and cosine curves y equals a. The sine and cosine curves y equals a sine of kx and y equals a cosine of kx, where k is greater than 0, have amplitude, the absolute value of a, and period 2 pi over k. An appropriate interval on which to graph one complete period is the closed interval 0 to 2 pi over k. All right, so the amplitude is the absolute value of this number in front. The period, you take 2 pi and divide it by the coefficient of x on the inside. Okay, so let's find the amplitude and the period of each function and sketch its graph. So, what is the amplitude of y equals cosine of 4 pi x? 1. Good. The amplitude is 1. Just going to write equals. What is the period?
4 pi over 2 is 2 pi.
And it's what?
Would it be 4 pi over 2?
No. Remember, you take 2 pi divided by k. K is 4 pi.
So
So
2 pi over 4 pi.
2 pi over 4 pi, which is the same thing as
1 half.
1 half. 1 half, what you say?
Just 1 half.
1 half, because the pi's cancel out.
Okay.
Okay, good. So, one complete period is 1 half. So, or I'm sorry, one complete period begins at 0 and ends at 1 half. Do you need me to write that or you got it? One complete period begins at 0 and ends at 1 half. Okay? Now, we know that. So what does that mean? When you are graphing this function cosine of 4 pi x, that means one period should be between 0 and 1 half. So remember what cosine of x is. Remember, cosine of x, cosine of 0 is here, so you would have this. But that's one complete period, right? Are you with me? Yes or no?
Yeah.
That's one complete period. So we began at 0. This right here means x is 1 half. Then, so we took it and we chopped it up, right? Okay. Now, if you want, it says sketch the graph so you can keep going. You'll get another one. What is this point? 1. Good. And then you can keep going. That would be,
1, 1.
it would be what?
3 over 2.
3 over 2. Okay. And then your next one would be what?
2.
2. Good. And you can go in the opposite direction as well. Okay? What questions do you have? So it's really not bad. It's a matter of taking this information and applying it and picking it apart. Okay? So now what we're going to do, we're going to do another example. We're going to do another example. We have y is equal to -3 sine of 6x. So your amplitude is what here? No. Amplitude is 3, right? Because it's equal to the absolute value of -3, which is 3. Oops, random mark. What is the period? Pi over 3. Good. Right? Because it's 2 pi over 6. 2 pi divided by the coefficient of x. Right? Because your k is whatever is in front of your x. So it's 2 pi over 6, which reduces to pi over 3. So that means that because you have a negative out here, remember your graph it takes sine and it flips it, right? So you're working with negative sine of x, not sine of x, okay? So remember that changes the graph. So I'm trying to figure out where I want to write. There you go. That's good. So remember, negative sine of x is in the opposite. It flips your graph. So here, is 1 period. It begins at 0, ends at what? Pi over 3. Good. Begins at 0, ends at pi over 3. And then you can keep going. I'm just going to use the dotted line to indicate it still goes. Does that make sense? What is the highest point? 3. Good. The lowest point is? -3. Good. Good. Okay. Shifted sine and cosine curves. Shifted cosine and sine curves. Let me move this up. There we go. The sine and cosine curves y equals a sine of k times the quantity x minus b, and y equals a times cosine of k times the quantity x minus b, where k is greater than 0, have amplitude, absolute value of a, absolute value of the number out front, period, 2 pi divided by k. Notice here the way I've given you these functions, k is factored out of this. So if you see kx minus a number, then you're going to have to factor k out to help you find out the horizontal shift. Okay? The horizontal shift is given by b. We'll go over an example where we have to do that. An appropriate interval on which to graph one complete period is the closed interval b to b plus 2 pi over k. So you use your horizontal shift, and then you take that and add to it 2 pi divided by k, or add your period to it. Okay? Does that make sense? Okay. So let's look at example 3. I'm going to move this up so we can have a little bit more room. What is the amplitude here? 3. Very good. Bless you. We have the amplitude is equal to the absolute value of 3, which is 3. The period, what's your period? 2 pi, good, because k is what here? 1, good. And then your horizontal shift, what is that? So it would be what? Notice that it's given to you as x plus pi over 4 on the inside. Yes, you're right. You're going to shift it to the left pi over 4. That's what's happening graphically. But we need to be able to write down the actual angle. So notice that here's x minus that. Because it's plus, that means we're subtracting a what? Remember, cosine of x plus pi over 4 is the same thing as cosine of x minus negative pi over 4. So your horizontal shift here is really negative pi over 4. Does that make sense? Because it says that the horizontal shift is b. So we have to make it look like it's in this form. Does that make sense? Or no?
Yes.
Okay. So we take the graph of cosine of x. We stretch it by 3, right? Because your 3 is your amplitude, it's the largest. So you stretch it by 3. The highest point is going to be 3. Lowest point is going to be negative 3. And then you shift it to the left, pi over 4. So you'll have negative pi over 4 here. And that's where you start your graph here. And then you go down. So that point would be 3 here. Actually make it look like it corresponds. So okay. And then we continue. And there you go. So remember, shifting it left, pi over 4 shifts everything where it crosses. So again, that would be 3 pi over 4 here. And then you'd have pi. And then you'd end at 7 pi over 4, right? Because we shifted it to the left, pi over 4. So shifting it to the left, pi over 4. So let me explain. Remember, whenever you have cosine of x, you had 0, your x values we chose were 0, pi halves, pi, 3 pi over 2, and 2 pi, right? So now you take all of those and subtract pi over 4. Whenever you do, you'll have this point. Bless you. This gives you here, this one, and that's what you end up with. Does that make sense?
Yeah.
Okay. So that's the graph there. Let's graph another one. Let's find the amplitude, period, and horizontal shift of y equals 2 sine of 2/3 x minus pi over 6. And let's graph one complete period. Now this problem is one that is what I was talking about before, saying that you're going to have to rewrite it, okay? Because here the k is actually with it. So we first need to rewrite this. So we're given y is equal to 2 sine of 2/3 x minus pi over 6. Which means that is 2 sine of, if we factor out a 2/3, that leaves us with x minus something. To figure out what this is, let's do an aside. 2/3 times y would be equal to pi over 6. So I can write that. So 2/3 times y is equal to pi over 6. So the goal is to figure out what y is, right? So y would be equal to pi over 6 times what?
3 halves.
3 halves. Good. 3's cancel. What are you left with? pi over 4. Good, so that's the blue. That's the blue. So, turns out that question mark is really pi over 4. Okay, now it looks exactly like the form we need it to be in order to identify the information, so we can find the amplitude. What's the amplitude? 2, good. Your period is what?
4 pi over 3.
No, it's not 4 pi over 3. You would take 2 pi and divide it by 2/3, which is the same thing as 2 pi times the reciprocal of 2/3, which is what? 3 halves.
3 pi.
Yes, you get 3 pi, right? Because your 2's cancel, and you get 3 pi. Good, good. What is your horizontal shift? Good. Your horizontal shift is pi over 4. That's a pi there. Okay? So, now, that means graphically we're going to take sine and do what with it? Can't hear you? You expand vertical stretch by 2, and horizontally what happens?
It's multiplied by 2. Or it's not the amplitude you're talking about, right?
No, not the amplitude. Horizontally what happens? Remember, horizontally is we find out what's happening horizontally by what's on the inside. To the right by pi over 4. This tells us stretch it being sine by 2. This says move it to the right pi over 4. Good, both of you. So, sounds like a bell. I was like, oh no. It is, we're 2 minutes over. We're leaving, I promise. I was like, dang, it's time for class to end. Okay, so, it's all good. So let's just sketch it. And so we take sine, so we know the largest value is going to be 2. The smallest is -2. We shift it by pi over 4, so that means we begin at pi over 4. And instead of ending at, we're shifting to the right by pi over 4. So we're going to end at 13 pi over 4 because we want one complete. Remember, one complete period is 3 pi, not 2 pi, it's 3 pi. So we have to make sure we get everything in, right? So this would shift pi over 4, and then we would go out, and we end at 13 pi over 4. And that would be 7 pi over 4, okay? So that's the graph of y equals 2 sine of 2/3 x minus pi over 6. One fact that we'll end with is that sine of x is the same thing as cosine of x minus pi halves. So in other words, sine of x shifts cosine of x to the, yeah, you got it, to the, did you say left or right? Right, very good. Shift it to the right, pi over 2 units. All right, have a great evening. I'll see you on Wednesday. Make sure you come prepared.